The conflict in Ukraine has fundamentally altered the landscape of modern warfare, transitioning from traditional maneuvers to a high-tech battle for the skies. Today, we examine the unprecedented drone usage and the rapid technological innovation that has defined this struggle. Both sides have integrated unmanned aerial vehicles into every level of command, from individual infantry squads to national strategic planning. Electronic warfare dominance is no longer a niche capability, but a core requirement for survival. As we move through this presentation, we will explore how low-cost technology is challenging multi-million-dollar platforms and what this means for the future of global security and military doctrine. One of the most significant developments is the rise of FPV, or first-person view drones. These small, agile quadcopters are equipped with explosives and piloted by operators wearing VR goggles. The cost-effectiveness is staggering. $500 drones are regularly used to disable or destroy multi-million-dollar armor, including advanced main battle tanks. Beyond direct strikes, these devices provide real-time battlefield surveillance, stripping away the element of surprise. Soldiers can now see around corners and over tree lines with minimal risk to personnel. This shift has forced a total reevaluation of armored tactics and individual soldier protection in the 21st century. The war has expanded far beyond the front lines through the use of long-range unmanned aerial vehicles. These systems, including the deployment of Shahed-type munitions, are capable of strikes beyond 1,000 kilometers. This range allows for the targeting of deep rear logistics and critical energy infrastructure, turning the entire territory of the combatants into a potential front. These kamikaze drones are often launched in swarms to overwhelm air defenses. The strategic impact on energy infrastructure has caused widespread power outages, affecting millions. This shift in capability demonstrates that geographic distance no longer provides the security it once did in conventional conflicts. To counter the aerial threat, sophisticated air defense systems like the Patriot and Iris-T have been deployed. These systems have achieved high interception rates for cruise missiles and drones alike, protecting major population centers. However, the battle is equally intense in the invisible spectrum. Electronic warfare, involving GPS jamming and signal spoofing, is used to knock drones off course or sever their links to operators. This constant cat-and-mouse game between offense and defense has led to daily software updates and hardware modifications. Without these defensive shields, the casualties and infrastructure damage would be significantly higher, highlighting the vital role of integrated air defense. The conflict has also revolutionized naval warfare through the introduction of unmanned surface vessels, or USVs. Systems like the Magura V5 and Sea Baby have changed the balance of power in the Black Sea. By using asymmetric naval warfare tactics, these low-profile, explosive-laden boats have successfully challenged the Black Sea fleet, damaging major warships and disrupting supply lines. These naval drones are difficult to detect and even harder to intercept, allowing a nation without a traditional large navy to project power across the water. This development has sent shockwaves through naval ministries worldwide, as the era of the uncontested surface ship appears to be coming to an end. While the technological aspects are fascinating, the human cost is devastating. Over 10,000 civilian casualties have been recorded due to ongoing airstrikes and shelling. The destruction of power grids during winter months has left millions without heating or clean water, creating a humanitarian crisis. Urban search and rescue operations have become a daily reality in cities far from the trenches. First responders often face double top strikes, where a second missile hits the same location minutes later. This slide serves as a reminder that behind every data point on drone efficiency, there are real communities facing life-altering consequences from these persistent aerial threats. The demand for drones has led to a massive industrial mobilization. Ukraine has launched initiatives for the domestic production of 1 million drones annually, utilizing decentralized workshops and 3D printing. This DIY tech integration allows for rapid prototyping and deployment of new features based on immediate combat feedback. This scale of production has caused significant global supply chain shifts, as components like motors and flight controllers are sourced in massive quantities. The war has turned the country into a giant laboratory for autonomous systems, with private companies and volunteer groups working alongside the military to out-innovate the opponent in a race for technological superiority. As we conclude, it is clear that the lessons from Ukraine will dictate military spending and strategy for decades. We are seeing the erosion of traditional air superiority as cheap, autonomous, AI-driven systems become more prevalent. Future conflicts will likely be defined by the mass deployment of autonomous swarms that can think and act without constant human intervention. For informed citizens and policymakers, understanding these shifts is crucial. The drone wars in Ukraine are not just a regional phenomenon, but a preview of a new global reality where technology, cost-effectiveness, and rapid innovation are the ultimate deciders of victory and security.